And now we'll continue on forward to see if we can find any shortcuts from having to use this quadratic formula with using so much of our time using this quadratic formula. We'll see if sometimes we might be able to glean a little bit of information just from using a piece of the quadratic formula. So today we're looking in particular at the discriminant. Now the discriminant, we'll see it's a part of our quadratic formula. Now let's just recall here the solutions of a quadratic equation. They're the x-intercepts of the graph. They are where the graph crosses the x-axis, so here and here in this particular case, and they're also known as the roots or the zeros of a quadratic. Now, we already know to solve a quadratic equation, if the equation factors, fantastic, we set one side equal to 0, we factor the other side, and then we set each factor of that of the side equal to 0, and we solve for x in that way. If the equation does not factor, we're forced to use the quadratic formula here. Luckily, now we're feeling a little bit more comfortable with it. Now, these are just two examples. This equation here we would be able to factor. The one on the right we would not be able to factor, and we'd be forced to use our quadratic formula. Now, let's take a look, because if we go into our quadratic equation, like we talked about at the end of the last video, it's possible to have, whether the parabola opens up or down, it's possible to have 0 real roots. In this case, we say that the roots are imaginary, and you'll go a little bit more into more detail there if you take math at higher years. And then otherwise, we can have a parabola that has a vertex right along the x-axis. If that's the case, then we have one real root. And otherwise, say we have a parabola that opens up and a vertex below the x-axis, then we'll have 2 real roots. Alternatively, we could have a parabola that opens down and has a vertex above the x-axis, in which case, again, we would have 2 real roots. Now, we're going to look at our quadratic equation without following through with the entire quadratic equation itself, and we'll try and determine how many roots, how many zeros, how many x-intercepts, how many solutions there are to a particular quadratic equation. Now, we have played around with our quadratic formula already a little bit. In this case, we have a new term for you. This is the discriminant. So the discriminant is the part of the quadratic formula underneath the square root sign. We call that, just so you know, we call that a radicand. Radicand. That's the piece beneath a radical sign. So a radicand. So the discriminant is the radicand of the quadratic formula. And that is the piece underneath the square root sign. That is b squared minus 4ac. So that is our discriminant. Okay, we are going to play around with the discriminant. We'll calculate the discriminant for various quadratic equations, and we'll sketch these quadratic equations, and we'll see if we can come up with some kind of a pattern that goes on. So in here, I'm just going to walk you through the very first one, although there are, I believe, 6 for you to go through. We're going to use Desmos to graph each of the following quadratic relations, and we're going to plot the vertex and any x-intercepts that are involved. So in this case, let's handle y equals x squared plus 10x plus 25. So if you take that, you go over to Desmos, you type that in along the left-hand side, and it'll plot it for you. I can see it's plotted here. My vertex is -5, 0, and that is also the only root involved. So my vertex right here, the sketch goes something like this. Here's a vertex, -5, 0, and x-intercept is also at the same point. That's -5, 0. Fantastic. So what I want you to do, I'm not going to go through all of them here in the video. That would defeat the purpose. I want you to put the remaining 1, 2, 3, 4, 5 equations into Desmos, and then I want you to sketch them over here in a way so that you've sketched the vertex and the x-intercepts. Those are the things we're paying attention to here. You can pause the video at this point. Please go through with that. It will be very useful to you. I'm not going to go through the answers, but you are going to be able to come up with sketches right here, and you're also going to be able to fill in something like this. So if you pause the video, you did those sketches, that's great. We're going to push on forward, and I'm just going to do the first one here for you. So the number of roots. Well, if we look at y equals x squared plus 10x plus 25 that we just sketched up here, we saw that there was only one root. If there's only one root, nice and easy, number of roots, 1. Okay, so the value of the discriminant. So the discriminant, remember, is b squared minus 4ac. So we'll calculate that right here. B squared, well, b equals 10, right? A equals 1. C equals 25. So b squared would be 10 squared. I know there's not too much space here, and that's okay. So 10 squared minus 4 times a, which is 1, times c, which is 25. And 10 squared is 100. I didn't leave myself enough space, and that's, like I said, that's okay. We'll try and be as efficient as we can here. That equals 100 minus 100. 100 minus 100, I know what that'll be. That'll be 0. So the value of the discriminant, b squared minus 4ac, equals 0 in this case. Our discriminant, is it positive, negative, or 0? In this case, it's 0. So what I want you to do, I want you to take a look at your other 5 sketches. I want you to take a look and calculate these 5 discriminants and come up with an answer. Is the discriminant positive, negative, or 0? And then try and see if you can find a pattern. So I'm not going to go through the answers for questions 3 through 7. You're going to be responsible for coming up with those on your own. This lesson is more of an exploration lesson rather than one that you'll just watch me go through. So I will say, pause the video now, solve those, try and come up with these 7 explanations, try and come up with an answer as you can, and then once you're finished that, you can unpause here and we'll continue forward. Good, so hopefully we have summed that up a little bit. Now, to bring it all together, to determine the number of roots of a quadratic relation, we look at the discriminant. If the discriminant is greater than 0, the quadratic will have 2 real roots. If the discriminant is less than 0, the quadratic will have 0 real roots. And if the quadratic equals 0 itself, the quadratic will always have 1 root. Now, we're going to use these rules here to work with the following quadratics, and we're going to calculate how many roots each one would have. That's the first part. So example A here, if we take a look, I can see that my A equals 4, my B equals negative 3, my C equals 1. Okay, well then my discriminant, B squared minus 4AC, that equals negative 3 squared minus 4 times A, which equals 4, times C, which equals 1. That equals positive 9 minus 4 times 4, that's 16. In this case, I'm working with negative 7 as my discriminant. Since, and that's what these this upside down therefore sign means. It means since the discriminant, b squared minus 4ac, is less than 0, therefore there are no solutions. Fantastic, we'll push right on forward. Over here, this time we're working, same as before, working on the right-hand side of the equal sign. I can see my A term equals negative 2, my B term equals negative 14, my C term equals negative 20. Okay, let's try it out. B squared minus 4AC, that equals negative 14 squared minus 4 times A, which is negative 2, times C, which is negative 20. 14 squared, negative 14 squared, that's 196. It's positive here because when we square a negative, the negative disappears. Minus 4 times negative 2 times negative 20, that'll come up with a negative number in total. So negative 4 times 2 times 20, that's negative 4 times 40, which equals 160. So 196 minus 160, that equals 36. In this case, since b squared minus 4ac is greater than 0, therefore there is one solution. And lastly, for C, we do need to be careful. Before we work with our discriminant, we must have one side equal to 0. So we'll need to adjust this equation. That's 0.5x squared minus 2x plus 2. So we've added 2 to both sides. Now our right side equals 0. Now it's ready for the discriminant. So A equals 0.5 here. B equals negative 2. C equals 2. And we'll throw that into our discriminant. So b squared minus 4ac. Well, that equals negative 2 squared minus 4 times a, which is 0.5, times c, which equals 2. That equals 4 minus 4, which equals 0. So since b squared minus 4ac, since our discriminant equals 0, therefore there is one solution. Awesome. That's the first part. The second part is analyzing these equations. So state whether we would solve this equation by factoring or by using the quadratic formula. Well, in this case, we cannot factor, and using the quadratic formula will come up with no solutions. We would have been forced to try the quadratic formula, but luckily, since we can double check with our discriminant, we don't necessarily need to do that for this approach because we know it will bring us no answers, no solutions. Next, we look at this one. We've seen this one before, actually. We are able to factor this, and anytime, let me see here. Anytime you see something like this, first you always try and common factor, and then you see if it becomes a simple trinomial. That saves you time, makes it even easier. But in this case, you can factor this. And lastly, a question like this, it certainly is not obvious right at the start where we can work with our where we can factor this off the bat. If you're clever, you should be able to factor something like this. Let me see. Absolutely, yes. If you're clever, you can. But otherwise, if you don't see it right off the bat, that's okay. You can jump into your quadratic formula. So you could use either. Remember, each time the question is solvable by factoring, it's going to be a little bit easier if you see that. If not, the quadratic formula will always work for you. So there you are. You should be ready to handle the homework at this point.